Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of scatterplots. This is standard 8.11a in the great state of Texas, and we are using item number 16 of the 2019 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a scatter plot here. Shows the energy in watts and the light output in lumens per watt. All right, so we've got our energy in watts, goes from 0 up to 120. And then the light output, so it's measured in lumens per watt. That's our y-axis. And you notice we've got this little squiggle right there. That just means we're kind of skipping. We're starting with 0 just to show it, but we actually kind of chopped off part of the graph. It goes from 0 to 40. But it's not like we're skip counting by 40 the rest of the time. Once we get up to 40, you notice we're skip counting by 2.5 each time. That's what that means. And so we've got dots kind of all over the place. It's kind of interesting. Look at all these dots up here on 80, right? So when you've got about, we're going to call that's 10. So maybe that's 15. 15 watts get you 80 lumens. But 60 watts also get you 80 lumens. This is about 75 watts, get you 80 lumens, and 120 watts get you 80 lumens. That's kind of interesting. But also, 120 watts also get you 75 lumens. So you've got, some that have two dots on the exact same X line, right? So definitely not a function because it doesn't pass that vertical line test. All right, so which statement best describes the association between the energy and the light output? All right, so as the energy increases, the light output increases. Okay, so we're looking for something that looks like a trend line. So it doesn't have to be an exact line, but a trend line just kind of encapsulates some data, is kind of near a whole bunch of data. And we're looking first, F would be as the energy increases, the light output increases. So energy is our x-axis. So as that increases, right, our light output increases. It's not going to be as perfect as just like a straight line like that. But you would like to see if the answer is F, your data kind of clustered around a line that looks like that, moving positively from the bottom left to the top right. And as you can see, you do have some data that's kind of near there, right? So that would work if it were just maybe these dots right here that I've circled. But what about this one? What about these ones up here on 80 that aren't over there by that 120? There's a lot of data that don't fit that particular line. So I can't necessarily say that because over half the dots aren't anywhere near that line. Let's check G. As the energy increases, the light output decreases. All right, so it would be another line. As the energy increases, goes to the right, the light output decreases. So that means we would be getting smaller. So we would start somewhere near the top here and kind of come down here. So this would be a line for G. Obviously, it would work for that dot right there. It would work for that dot, and some of these maybe work for those two. But then you've got, again, a whole bunch of dots that are nowhere near that line, especially all these over here. None of these work for that line. So it's not F, it's not G. Let's check H. As the energy increases, the output remains the same. All right, so as that goes there, so we would just have to randomly try to draw a line that goes straight across. Maybe we could draw a line there. It would hit some of those line dots, but not all the others. We could draw a line up there at 80. It would hit these dots, but then it would skip all the others. So there's no straight line across that would hit all the dots. So our answer is going to be, look at that J, there's no apparent association. That means the dots are all over the place. They don't fit into a box. You cannot encapsulate most of them into a straight line. So there's no apparent association. The dots are everywhere. And our answer is J.